Bismillah ar-Rahman ar-Rahim. Today lecture is about the distribution of molecular speeds. The Scottish physicist James Clerk Maxwell first solved the problem of distribution of the speed in a gas containing a large number of molecules. And he named this distribution as Maxwell speed distribution or Maxwell-Boltzmann's distribution. It's describe the distribution of the speeds among the particles in a given sample at a specific temperature. The distribution is often represented graphically with the particle speed is drawn along the x-axis and the relative number of particles along the y-axis. The Maxwell Boltzmann distribution of the speed for a simple of case at temperature T containing n number of molecules with mass m is mathematically represented as nv is equal to 4 pi n m divided by 2 pi kt 3 by 2 v square e to the power minus mv square divided by 2 kt, where n is the number of molecules per unit speed interval having the speed range between v and delta v. Therefore, nv delta v is a dimensionless quantity which provides information about the number of particles or number of molecules in the range v and v plus delta v, where n is the number of particle, m is the mass of the particle, k is the Boltzmann's constant, t is the temperature. So this is as a whole is mathematical form of the Maxwell-Boltzmann distribution for the speed. Now this mathematical representation is shown on a graph where this one is the x-axis which shows the velocity and this side is the y-axis which shows the n into v. Now if you look at the mathematical representation, it only depend on the temperature. This is why this, if you draw that for nitrogen at a temperature of 298 Kelvin, which is a room temperature. So this graph shows there are three different velocity, which is this one, which is the maximum velocity, which is the most probable, where all maximum of number of particle having this type of velocity. That is why this is called most probable velocity. And then we have an average velocity, and then we have the vrms velocity that we will discuss later on. And the area under this curve shows the nv into delta v, which shows the number of particles. Now the speed at the top curve that I have shown here, that shows the most probable speed because the number of particles have the same speed. Similarly, dependence of the Maxwell distribution on the temperature is shown in the figure. This figure show the distribution, Maxwell speed distribution for different temperature. This is temperature T1, this is temperature T2. If you look here, I have shown here that T2 is greater than T1. So it means T1 is smaller, the temperature is smaller, so the small number of particle have a lower speed. So that is why maximum of the particle have a smaller speed, and that is why the slope is smaller. And similar, this is having a broaden slope, so that is why it have large number of velocity. Because the temperature is larger, the velocity of the particle will also be larger, because the kinetic energy increase with the increase in temperature, and similarly the speed is also increasing with the increase in temperature. This is another graph which is shows the dependence of the Maxwell distribution on the molecular mass. This is the xenon, which is having molecular mass 132. This is argon, which is having molecular speed 40. This is neon, which is molecular speed 20. If you look at this, so this is having a large, this is heavy, this is heavier, this is middle mass, and that is the smallest mass. So as the mass is larger, the particle will move, or its velocity will be smaller, and so that is why it will have a smaller range in slope. And this is as the mass becomes smaller and smaller, what will happen? As the mass becomes smaller and smaller, the speed of the particle will increase. So if you look at this one, the graph is broadened.